Calculate the number of moles of gas present in the container of volume 10 liters at 300 Kelvin if the manometer containing glycerin shows a 5-meter difference in level as shown in the diagram. Given density of glycerin is 2.72 grams per ml and density of mercury is 13.6 grams per ml. Okay, so we have the volume of air 10 liters, we have the temperature of air 300 Kelvin, we need to find the number of moles. What else do we need for this? PV is equal to nRT. We have T, we have V. We need to find N. R is known. P is something which is to be found yet. So for P, we have been given this manometer diagram in which this liquid is glycerin and not mercury. Note that. So first of all, let's find out what pressure would 5 meters of glycerin correspond to. Basically, let's say that this is the density of glycerin, G, times height of glycerin is equal to 1 atm. Let's find out what height of glycerin do we require for getting a pressure of 1 atm. And if we talk about this in terms of mercury, we know that this will be equal to the density of mercury into G into height of the mercury column. And for 1 atm, if you remember, what does height of the mercury column come out to be? It comes out to be 76 centimeters. Or let's write it as 0.76 meters. Okay. Now we have been provided with rho G, we have been provided with rho Hg, and we know the height of the mercury column. G is something which gets cancelled out from both the sides. So now the height of the glycerin column for 1 atm would be equal to rho of mercury divided by rho of glycerin into 0.76. When we solve this, plugging in the value of rho mercury as 13.6 divided by rho glycerin, which is 2.72, multiplied by the height of the mercury column, which is 0.76. This comes out to be 3.8. So therefore, 1 atm pressure would correspond to 3.8 meters in the glycerin column. So now we have 5 meters of the glycerin column. What would these correspond to? Applying simple unitary method mathematics, we can say that 3.8 meters corresponded to 1 atm. So 5 meters would correspond to 1 divided by 3.8 into 5, which comes out to be 1.315 atm. Okay. So basically, if you look at this figure, 1 atm was the atmospheric pressure acting, and this 5 meters corresponds to 1.315 atm according to our calculations. So what is the total pressure at this point? This total pressure comes out to be 2.315 atm. And this will be equal to the pressure at the same level, that is at this point, point A. And the pressure at this point is due to the gas occupied inside the container. So now basically we have that unknown parameter P as well with us. Now plugging in the values of P, V and T to find N, we have P as 2.315 into V is given to be 10 liters divided by R, which is 0.082 divided by T, which is 300. This comes out to be 0.94 moles, which is our answer, the A option. So the concepts of how a manometer works what is the pressure at this point A, and how is the column of the liquid responsible for that pressure. These concepts are very important for solving questions such as these.